So here we have some functions from a previous final exam, and we want to figure out how to determine the domain of each of these functions. And sometimes it can be a little complicated as to see how we should approach finding the domain of a function, right? So first, we want to look at the first function that we have here, f of x, and we say that we have 5x over x minus 3. Now we ask ourselves, what does a domain mean, first of all? So before we even continue, we always want to understand what is it that we're looking for. So the domain of a function is the set of all input values, in this case all the x values, that have a corresponding output value or a corresponding y value. So which means that if I plug in an x value, I should get a y value back. If that x value has a corresponding y value, then it's in the domain of my function. So then we ask ourselves, is there always going to be an output value for every input value that I have? Well, if I look at this function here, I realize that it wouldn't always be the case. And why not? Well, if you see this is a fraction, correct? And what do we know about fractions? We know that the denominator, whatever that is, cannot equal 0. If the denominator were to equal 0, then we have something divided by 0, and that cannot happen. That creates a function of a fraction that is undefined. We cannot divide by 0 because it goes against everything we know about algebra. So we say, okay, let's look for the values that are not in my domain, because we probably number them out. We can probably count them on our hands. So we say, hey, let's find x values that are not in domain of f. So I want to find the x values that are not in my domain. If you're not in my domain for this particular function, that means that you make my denominator equal to 0. So we say, hey, what's my denominator? Well, my denominator is equal to x minus 3. If that's my denominator, I'm going to see what's the x value that makes this expression, my denominator, equal to 0. So I set it equal to 0, and I solve for x. And this is quite simple. You add 3 on both sides, and you see that x equals 3. So x equals 3 means what? This means this is not in domain of f. Why is it not in my domain? Because if I plug this in, this value of 3 into my function, I get 3 minus 3, which is 0. Anything divided by 0 is undefined, so that means that this guy cannot be in the domain of f. It can't be. But then I find out, wait a minute, is there any other bad x values? And since my denominator is the only thing that can go wrong if it were to equal 0, and I see that this is the only value that's bad, so everything else is okay. So this is enough. Then I can say, and what helps a lot is if I construct this number line here, and I single out the x value that I am not going to include in my domain, which happens to be 3, and only 3. But everything else, all other x values, are perfectly fine. So then, now I can say my domain for f of x is the set of all x values such that x cannot equal 3. And this is known as the set builder notation. I would like to write it, though, in interval notation. So then if that means that x cannot equal 3, and I look at the graph that I have here on the number line, I see that I have one interval here, and I have another interval here. This interval to the left of 3 can be expressed as if I go to the left, infinitely to the left, I go towards negative infinity. I stop right at 3. This is my first interval here. And the interval to the right of 3 is going to be everything from 3 to infinity. So you can see that I'm kind of splitting this interval into two intervals. What was once one number line, now it's split by 3, to the right of 3 and to the left of 3. This is to the left of 3, this is to the right of 3, and I'm excluding 3. And all I need to do is put the union symbol, and this would be my domain for this function in interval notation. And so we're done with this one. And this is the simpler one, of course. Now let's go to the next guy. Now g of x also has this kind of fractional expression here, right? And again, the question would be, what do we do with the numerator? Well, if you look at the numerators for 5x, for f of x, and g of x, x minus 5, nothing really goes wrong with the numerator in these cases. I can plug in anything to x in numerator, and it's all good. The real issue for both of these problems is that the denominator can't equal 0 again. Because I have a denominator here, but this time, it's a little different. What makes it different? This little square root. So first, I want to say that my denominator cannot equal 0, right? So I want to find what are the x values that make my denominator equal to 0, so I can exclude it from the domain. So here I can say, well, what underneath this radical makes it equal to 0? Or I can just solve for x, right? So one way you can approach this is to get rid of the square root. So then I would have to square both sides. And when I take the square root and I square it, I cancel out one another, right? They cancel out each other. So I get x minus 2 equals 0 squared is 0. So then you solve for x and you get x equals 2. So what does this mean? X equals 2 is not in domain. This is not in my domain. Why is it not in my domain? Well, if I were to plug this into my function, I would get 2 minus 2 in the denominator, which is 0. The square root of 0 is 0, and anything divided by 0 is undefined. So this x value makes my function undefined and hence cannot be in my domain. But that's not the whole story. Now, we took care of the fact that my denominator cannot equal 0. So this x value is the one we take away. However, you see on this problem, we took away x equals 3, but everything else worked because this was quite a simple expression. This won't necessarily be the case for this guy. Why not? Because we had to go and consider what happens with the square root function. This guy really can be considered as a combination of two functions. And one of those functions is the square root, which is underneath. Now, the square root function, what do we know about the square root function, the parent function, square root function? We know that whatever is underneath the denominator cannot be negative. So then what do we usually say? We usually say that x minus 2 must be greater than or equal to 0. Because you can't have a negative underneath the square root. It would be an imaginary number. And we're not going to deal with imaginary numbers. So we solve for x and we get x is greater than or equal to 2. So in this case, I'm actually being able to find what it is in my domain. And this is in my domain for this particular part of the function. However, we have to also pay in mind and into consideration what we found originally. We found that x cannot be in my domain, but x has to be greater than or equal to 2. So the only way that's possible for both of these things to be true is if I say, I can't include 2, but I could include everything bigger than 2. So 2 is actually excluded. Everything to the left of 2 is excluded because it would make the square root negative, but everything to the right of 2 would be okay, would be in my domain. So with 1 and 2 together, I get that my x value must be greater than 2. So then my domain of G would have to be, you can say the set of all x values such that x is greater than 2. Or in interval notation, I can say that it goes from 2 to infinity. So this would be my domain. So you see here in this problem, we have to take a little more consideration with the square root and what's underneath the denominator. Okay, so we did A, we did B, now let's look at C. Now C, we have to consider both the numerator and denominator. We always want to consider the denominator, and usually we do that first because we kind of already understand what we have to do, right? The first thing is, we know that my denominator, whatever that is, cannot equal 0. So then what do? We find those x values that do make it equal to 0, and then we take them away, exclude them from the domain. So we say, okay, what's my domain? What's my denominator? It's x squared minus 5x plus 6. Set it equal to 0. Now the nice thing about this is that this expression is a trinomial, and I can factor it, I can solve it, right? So this I can say what two numbers add to negative 5 but multiply to positive 6. Well, it would be x minus 2, x minus 3, set it equal to 0, and then we do this little t-chart thing, and then say x minus 3 equals 0, let's say x minus 2 equals 0, then I say x equals 2, then I say x equals 3. So then, what do I know about these guys? I know that these make my denominator equal to 0, which makes my function undefined, which means not in domain. So I will exclude them from domain. But that is not all that we have to consider. That's one of the things we have to think about. The second thing is, now we have to look at, wait a minute, in this numerator, I have a square root function. Now, what do we know about square root functions? We know that in order for this to have a corresponding output value, whatever expression is underneath the square root must be greater than or equal to 0. So I say, what's my square root function here? I got x minus 1. And I know that whatever is underneath here must be greater than or equal to 0. So then what do I say? X minus 1 is greater than or equal to 0. Solve for x. So x is greater than or equal to 1. So in these problems for the square root, I can directly go and find what the x values are. When I have a fraction here, I have to actually set the denominator equal to 0 and solve for the x values that I'm going to exclude. But with the square root functions, I exactly find what those x values are, or the interval that those x values are, merely by the fact that it's a square root function. And I know that the square root function cannot be negative, but it has to be non-negative or greater than or equal to 0. So these x values, when they're bigger or equal to 1, make my expression underneath the square root greater than or equal to 0. So these guys are good. So I'm going to put 1 and 2 together. I have to piece these two things together. Now, if I piece them together, also drawing the number line helps, right? So I'm saying with number 2, I'm saying that everything from 1, right? If I have 1, everything from here, including 1, to the right works. Everything works. But at the same time, I have to consider that x equals 2 and x equals 3 are not in my domain. So everything bigger than 1 is good. But these two guys, even though they're bigger than 1, cannot be in my domain because I need both of these two results to coincide with one another. So then I have to say, I have to exclude 2 and I have to exclude 3. So everything that's bigger than 1 except for 2 and 3. So then what would my interval notation would be? So the domain of h of x would be everything from 1 all the way to 2, excluding 2, from 2 to 3, excluding 3, 2 and 3, and including everything bigger than 3. So this is how we approach finding the domain of functions. When we look at them, without looking at their graphs and solving them algebraically, we need to have more experience and more confidence in ourselves and understanding what the functions that they give us are, and the little things that we know, such as denominator can equal 0, and such as the square root function cannot have a negative number. These little principles are utilized throughout our work. So I hope this helps.